Hi everyone, welcome to Cisco IoT Technologies and Solution and with respect to Fog and IOx. In this particular series, the agenda is to cover the various IoT Internet of Things technologies and what is Cisco take on this, means what type of product Cisco already have in the market to provide Internet of Things solution. So in this, what I will do that I will start with the theoretical portions. I will cover that what is Cisco technologies, what is that portfolio, then what is fog, what is the IoT stack, fog architecture, IOx architecture. So all these things, first of all, I will cover, and you can think this as a theoretical aspect of all these things. Once we understand about what is the things, what is the fog, what is the IOx architecture, then I will go and show you inside the lab section that yeah, Cisco has IoT router. Say in my example, I have taken IR industrial router 8 to 9, and on that iOS, how we can go and log or create some functionality with respect to IOX. So you'll come to know in this section. Then I will go and log to the fog director, and inside that fog director I will call say iOS or IR router, and then once it is inside the fog director, then we have various options like we can monitor, we can start, stop, add applications. So all those things you'll come to know and understand in this fog director lab section. Let us discuss more on this. So in IoT, what is the things? These are the things. These devices from where I am getting the input, these are the things. So somehow if I have interface, and that interface means all these smart devices, if I am able to connect them with a network, then what is the possibility? Then I have possibility to control them, optimize them, analyze them, monitor them, and automate them. Now, if we do these things, means if we achieve this target, then obviously we can take smart decisions, means my businesses that they can take a smart decision. Let me go to the next slide. And here you can see that what will be the business outcome. So once your things or smart things, they are networked, then we can do all sort of networking things. Once we achieve to that goal, then the business outcome is that of higher product quality, improved operational effectiveness, better decision making, new product and service offering. So all those possibilities we have once we connect these things into the network. Okay. Now, how to think about IoT for my industry? You can see here on the top that we have a list of businesses like connected healthcare, smart city, a stadium, retail, education, SP. All those things, they are connected with the cloud. So not only we have IoT, but we'll come to know in this series that we have say IoT director called Fog director, and it can easily be integrated with cloud. So we have something called cohesive solution, IoT plus cloud, and that in that case we have real-time monitoring, real-time what you can say that real data we have, and those real data, real-time data we are sending to the big data for analytic, for uh, say production or optimization. So all those important things or all those optimizations we have. So once we connect all these things, all these businesses, because things are inside business. So if we are thinking about the things, so these are the things here. And obviously these things are associated with business. Now these businesses, they are connected with the database, in turn analytic engine, and our uh, say application team or our development team. They are developing apps for all these endpoints or all these nodes. Okay, so that is the business improvement or the outcome for us in terms of the industry, means the application of IoT inside the industry. Now where Cisco fit in? What is the Cisco role in this? Cisco role inside this, that for all these analytics, Cisco has their devices. Here you can see in this particular layer, even in the upcoming series, you'll come to know what is the Cisco portfolio for that. Now, in terms of Cisco, they have routers, switches, Wi-Fi devices, security gateways, all those products already there into the Cisco portfolio. Plus, Cisco has Fog Director, and here you can see the fog. In the IoT layer approach, you'll come to know that where all these components fit in. But yeah, these endpoints, they are connected with the fog, and these Cisco devices, they are connected with the fog. And fog architecture is something that it is taking the things abstraction. So think these things or whatever IoT inputs you have, that will be abstracted inside the fog, and fog is connected with the development team. Fog is connected with the cloud, and that's why it is giving all real-time application, real-time inputs, and we have big data connected. So that's why we are getting efficient business outcomes here. These are the big players who is already using the IoT. So I hope you understand what is the IoT strategy, and in the upcoming recording will come to know what is the Cisco portfolio, means which type of devices Cisco has, and I will walk you that inside Cisco where you will find all this information. In this section, we are going to discuss about Cisco Internet of Things technologies and solution, means in terms of Cisco, what type of solutions Cisco provided to the end customer. And when we are talking about end customer, so end customers are not only the computers or laptops or phones or any human interaction, but you have to think this in a broader manner, means you have to think this in terms of sensors, smart object, device clustering systems, and any machine to machine interaction. And these are my input or end device. So if you know about say SD-WAN or any cloud technology, at that time what we are telling or what we are interpreting, that we have something called underlay, and inside that underlay we have our end device in the data center. But in case of IoT, our underlays are these things like analytic and modeling, predictive maintenance, precision agriculture. Means these are the end nodes or the touch points from where we can abstract the things, and then we can say operate, optimize, analyze, all those things will do. Okay. Let's see that where Cisco fits into this and what type of products already Cisco have in this particular IoT domain. We have something called fog computing, network connectivity, some physical devices related to security, data analytics, management automation, application platform, and these things where you can find. You can go to, let me show you that. So you can go to www.cisco. Let me show you that. Say cisco.com/go/IoT. Once you reach to this particular URL, then you will get the complete portfolio of Cisco, which type of Cisco solutions already there into the market. In this particular page, let me scroll down. Here you can see that we have devices related to IoT networking, some control centers, IoT management, application, iOS and fog application, and this is IOx. In this particular course series, you'll come to know that what does it mean. What Cisco is telling that iOS plus Linux will give you equivalence of IOx. Okay, so if I go to these uh, tabs one by one, say IoT network, I already opened here just to save the time. IoT networking, if you go to IoT networking, then you will find different type of networking devices, and these are, say, IR, integrated routers, some gateway, switching. All these hardwares are present, and in this particular course series I have taken one example of IR800. So let me write here IR800, that is the industrial router 800. In particular I use 829. Okay, but here you can see all these things, and good thing of all these devices will come to know about the IOx infrastructure, that you have underlay or you have the framework of operating system called Cisco IOS. On the top of Cisco IOS, we'll come to know about this. We are running guest operating system called IOx. Okay, and that is again the Linux based operating system. We'll see that. But suppose if you want to know detail about this, you can click, say, industrial routers, click there, and it will redirect you to the industrial router pages where you will get the information about all those devices. So let me scroll a little bit down. Here you can see various series of devices I have. Something called 500 WPAN, ASR 900, 1000 series, 2000 series. Okay. So likewise, you can check all these things. In this particular series, I'm going to cover IOx and fog appliances, because that is the basic and that is one of the most important thing here in Internet of Things learning. So you can go and you can check various options and various product line, the features, and even you can search the white papers, the case studies, all those things you can check. Let me go back to our PPT, and you have this series of Cisco Portfolio or Cisco already supported documents or appliances. Now already we know that, okay, my input will be these intelligent devices. This is again one framework from the Cisco IoT portfolio, where you have these endpoints. Obviously you need some type of interface. Sometimes it is termed as a bring your own interface, BYOI, because you need something, you need some input. So either some sensors or some sort of mechanism will be there, that from there you will get the input, and then obviously you can do some analysis, optimization, or other things that will check. In this framework you can see that already these companies, these are using IoT services like GE, SAP, Bitster, OSI Soft, these companies. Okay, in our infrastructure, that will come to know in the upcoming sections, that okay, I have IOx application manager, I have IOx, and here you can see I have these devices. These are the Cisco portfolio devices, something like industrial switching. I have IE 2000, 3000, CGS 200, like that. Industrial routing, we have these routers. Industrial wireless, we have these wireless devices. Field network, we have these devices. Then we have very important this ESR, embedded service routers, that we can run, and this is again the Linux operating system. The command again will be very much similar to the Cisco normal operating system that we used, or that we know how to use that. Then we have some connected safety and security. Okay, so this is the Cisco portfolio, and the major role played by this IOx that we are going to check. Let me go to the next slide. And here, this is one type of summary slide where you can see all the input interface appliances I have or devices I have. If we categorize, they will come under, say, government, manufacturing, energy, minerals, transportation, B2C. Okay, so all these device you can just check that can be associated with Internet of Things. That means we can take the input, obviously that input in the real time. So we can take the real time input, we can analyze them, we can operate them, we can optimize them, and obviously we can generate various type of reports, and we can give some security features as well in these devices. In this section, let us discuss about the fog. Before that, we'll see that what is the growth of Internet of Things. Here in this diagram, you can see that initially one person was holding one mobile device, but as predicted, say after 2020, one person will hold, say, at least 6 IP devices. And that is the human behavior or the adoption rate of the digital infrastructure that is 5 times faster than the electricity and the telephony. Okay, so that means that the drastic increase in the endpoints, or we can say that things, you can see here in the 7-layer architecture that this is the things in layer 1, like devices, sensor, controllers, etc. In this particular fog, I have connectivity and edge computing. Inside layer 2, you can see communications protocols, network, M2M, Wi-Fi, telecom, like that. Then we have cloud, big data for data analysis, data ingestion, business value like people, process, and applications. So from here, say from layer 6, I can make custom applications, and that can be integrated with fog, and that will take the say data from the things. Okay, so that is the overall 7-layer architecture we have for IoT. And in this architecture, basically you will get everything. Like from here you are getting the input. This is your fog. We'll see that the fog terminologies like IOx in this particular course series. Then obviously you need some transport from place A to place B, C, like that. And after layer 3, from here, say from layer 4 onwards, we have data for reporting, analysis, optimizing, and in layer 7 we have customization of data. Okay, so everything you can see that uh, in this particular 7-layer IoT things, and obviously in the upcoming slide we'll discuss more on this. Let me go to the next slide. Now the question is, what is fog? Now fog computing is nothing but an architecture that extend the compute, networking, the storage capabilities from the cloud to the edge of IoT. So that means here in the diagram you can see that you have the cloud and you are matching the cloud to the things. So these are the things, cloud to the surface. It's something like extend the cloud out into the physical world of things. Okay, so that is the fog or the fog computing. And why we need fog computing? Because we need response time, mobility, geo distribution, distance between client and server. Means we need some optimization while we are taking the data, and those data. So let me show you in the next slide that what is the actual need of this fog computing. Actually, this one is the slide. So let me go back and I'll come and answer the need of the fog. Before that, let us see that what we have at present, or what is the architecture for the cloud based data center. So we have endpoints, say laptop, desktops, mobile or other sensors or other devices. Then we have core network domain. Then we have data centers plus the cloud integration. Now if you fit fog inside this, means if you fit IoT inside this, then what will happen, that you are adding one extra layer in between, that is in terms of response time transaction, in terms of infinite storage size. So once we are adding this, because of the 7 layer of IoT uh, infrastructure or layers, you can see that we are expanding the business to the infinite. That is the word here. So we are expanding the capabilities because we have the integration for the data optimization, we have the integration for custom made applications, we have the integration with the cloud. So whatever existing infrastructure I have, I am adding that infrastructure with the things, and that things will be extended in terms of low latency, in terms of infinite storage. Okay, so that is the concept behind the architecture of the IoT. Once we use IoT, we have this edge location, low latency, geographic distribution, large number of nodes, wireless access, real-time analytic or analysis, and heterogeneity. And for all these characteristics or features, basically we have Cisco supported devices that we have seen in the Cisco portfolio, that for everything we have Cisco devices or Cisco support for that. Okay, so let me go to the next slide, and this will be last for this particular recording. What is the significance of this slide is that in this slide uh, it is showing that what if you have non-IP sensor or non-IP device, at that time how fog they will get the input from that. The term is something like bring your own interface, means you need something from where my fog will get the input, and that is again the logical in terms of what layer 7 approach we have. So these devices, this layer 1 devices, uh, suppose if they don't have IP capability, still my fog should have capability that somehow they will get input, and then for further processing it will send that to the application layer or it will send to the cloud. Okay, so this is the strategy in the Internet of Things or the integration of IoT with the cloud. Let us discuss about Cisco Fog implementation. And here you can see that Fog, we have data in motion option, and we have option IOx, that is Cisco IOS plus Linux. In this particular series, I'm going to focus on IOx. Okay, and what this fog will do, although we know that fog is there in layer 1 and 2, means it will take the abstraction from the things, and from here you can actually install all those devices. You can monitor all the applications. So one portion, the application builder or the developers, they are developing the applications, and from the other side you are deploying and managing the applications. Okay, so that is the complete life cycle of a things and things related to application. Now let's check this slide. Here you can see that what are the things that we can do with help of fog, that we can deploy the application to the edges, we can manage the devices, we can monitor application to the edge, we can monitor the device. So let me log to the fog. Let me show you the fog dashboard. Here I am inside the fog. What are the things you will find inside fog? That you have apps, means the application, then you can uh, manage or monitor the devices. We have this cartridge option, then the setting. In the upcoming lab section, we'll see that how we can use the devices and cartridges. Because I'm going to use IR 800 for this lab purpose, so I will show you that. But here you can see that, yeah, you have option for devices, cartridge, settings, although at the moment it is blank because I haven't attached any device in this, and in the upcoming lab section we'll do that. But these are the things that we can monitor, manage with help of fog. Now, while using the fog, the application life cycle is easy to use. Managing application resources, like we can manage the IOx resource utilization like CPU, memory, bandwidth inside that fog. Display per application per device historic trend, means overall we can manage the IOx, that is the Linux operating system, attached with the application. Okay, and because this fog director, this fog, we can integrate with the cloud, we can integrate with the database, we can integrate with the application development. So it's like easy to maintain the complete life cycle of the things related to applications, correct? Okay, now once you have all the application installed inside the fog, in the app section you have these things, like from here you can view the installed application, you can check the status of the app, that application is ready to deploy or not, what is the readiness, resource consumption dashboard. All those things you will get from the app section. Let me go to the next slide. In the app section, suppose if you are checking a specific application, you can check, no problem on that. Even here you can see the number is 16. Then in the monitoring section, you can monitor the app deployed on devices, app success and failure, app resource monitor. In the device section, you can check the device resource view, device view and associations, IP and the configuration, last heard status, adding new devices. Yeah, obviously in the upcoming section I'm going to add a device, so there you will get more about this fog dashboard. Okay, so I'm good to close here. In the next section we'll study about the IOx architecture. In this section we are going to learn about IOx architecture. This architecture you will find very modern, innovative, and it's very realistic and close to the application. How it is? You can see here iOS plus Linux equal to IOx. What does it mean and what type of capabilities it will add or enhance in the current Internet of Things, that we'll learn. First of all, if you see the basic framework, that you have the hardware, on the top of that you have hypervisor, and then you have say Cisco iOS operating system, then you have virtual device server, something called VDS, and then we have guest operating systems. Okay, so this is the architecture of one of the routers, say IR8X9. Now, if we talk about the framework, so what will be the framework for the IOX? The framework is something like this. In this framework, you will understand, you will come to know that, okay, you have some hardware here, and then you have iOS. This IOX is actually the entire framework, means everything is glued inside this. Now, to create the application or to build the applications, we have application store, we have application manager, we have SDK related to that. What does it mean? It means that it is supporting various programming languages. So let me show you that it is supporting, say, Python, Java, containers. That is obviously the framework for the applications. Now in this particular framework, you can see here that you have the underlay things or nodes. Then we have the hardware platform, and then we have the entire IOX infrastructure, where we have IOX infrastructure. This IOX infrastructure is something like device-specific integration to make Internet of Things related, uh, what you can say, the fabric. IOX is actually the fabric for the fog that we have seen earlier. Now, if I go one by one here, so this is the devices. They are connecting here to the actual Cisco hardware. Then we have this complete infrastructure where we have, say, app enablement framework. So all these things are app enablement framework. We have fog middleware. We have IOX infrastructure. Obviously the runtime will be there. And these things are supporting Java and the other programming languages. Then it is connected here with the fog. And then we have something called SDK development or the other stuffs. So now you can see that how modernized this framework is, that not only you have the core, and that core is a Cisco core, but it is open towards the northbound for the app enhancement or app development, and again we can monitor, manage, operate, do various things with help of fog director. Okay, now let us go back. Obviously it will use the shared resources like CPU, processor, RAM, everything. We can see all these things over the fog director. This is one mechanical diagram where you can see that, okay, you have the hardware hypervisor, you have the host OS, the app hosting, and then the various custom made applications, and parallelly you have the operating system. You will see all these things in the lab sections as well, where first of all we log to IR, say 800. From there we enable the guest operating system, means we enable the SSH for guest operating system, and then we'll log to that guest operating system and we'll check all those things. Okay, again this is one way to represent that. One hypervisor, 3 virtual machines, say operating system, guest operating system, and VDS. Okay, once you do all those things, then it will increase the capability. Why it is needed? Because this is something called device specific knowledge needed to build application. And what are the benefits we have? We have benefits like it is device agnostic application development, built once, deploy anywhere. Means that is the reusability of the programming, that you have to build that program once and then you can reuse or redeploy or not deploy to all the other to all these other frameworks or all the other places. Let us learn about the supported platform. In this particular series, I have used 8 to 9 just to show you about the lab and all the operations over 8 to 9. In 8 to 9 platform, you can see that it has type 1 hypervisor, that is Linux secure, runs on router hardware, and all those things that we have already discussed in the previous sections. What types of features are supported in 8 to 9 or 8x9? You can see that we have various features related to layer 3, layer 2 security, quality of service, application awareness, manageability. So it's very much similar that what we have in the Cisco devices. Here also you will find in this 8 to 9 or 8x9. Okay. Now again come back to our architecture where we have the logical. So first of all we have the hardware and then the hypervisor. So this is the logical diagram actually, where I have the iOS, VDS and GOS. So let's see one by one all these components. In this hypervisor, if you want to check, you can check the version like this, show platform and then the hypervisor. Now hypervisor is installed from the bundle IOx image. Bundle image cannot be booted, only installed. This is the command from where we can install the bundle image if it is present in the flash. Let me show you that how you can check the hypervisor. So you can type show hypervisor. You have to check like this, show platform and then hypervisor. So this is the version, and then if you check in your platform what other options you have option related to bundle install, hypervisor, interpreter, LED, NVRAM, etc. Now suppose if you want to install the image, then what you can do, you can check the bundle install, means this is the command, and from the flash you can install this. Okay, so this is the way that you can install the hypervisor. Now the other important component, that VDS. Why VDS is important? Because this virtual device servers is a separate virtual machine that owns shared device, as iOS and guest operating system need to access some shared device such as say USB, storage, eMMC, say virtual layer 2 switches, like that. Now the VDS provides communication, and that's really important, channel between the virtual machine using emulated Ethernet interfaces. Because we know that this VDS is also a part of share in the hypervisor. So if you see this IOx hypervisor and then the scheduled policy, by default it is 50-50, but suppose if you give 10% to VDS, then you have to give 90% to guest OS. Okay, so this also you can check. Let me go to my device and I can check this. The command is IOx hypervisor. So let's go to the global configuration mode, and then if you do the schedule policy, you can see this is the share. Okay, now again you can have a look on this slide as well. Even I can go to a particular guest OS, and that I will show you in the upcoming lab section, that how you can telnet or SSH, actually not telnet, how you can SSH to guest Linux type of operating system. And because this is the Linux operating system, then you can execute various Linux commands here to check, verify the options. Okay, so that option will be always there. Then finally we can check the guest operating system. Now this guest operating system is Yocto project 1.4, and with the service enabled, say IPv4, IPv6, DHCP, NTP, AAA, Python, basic debugging tools like TCP dump, top, etc. So these features will be there. Now this guest operating system is installed through IOx bundle. Install process can be start stopped with help of its parent like iOS CLI. Now how we can check it? Uh, Let me go to the device. Let me show you that. Before that, this is actually very important section that you can check, that I have a Yocto Linux application. This is the framework for the guest operating system. Okay. Now let me go to my CLI and I can type say guest OS 1, and then I have option to partition, image, restart, start, stop. Okay. Obviously in the coming sections we have a lab in more detail that how you can enable the DHCP over IR and how these guest operating system they will take those IP addresses. So for that you have to type or you have to verify like this. So IOx host list detail. What does it mean? That you can check like this. Say host list detail. It has IP address 1.8 and all these information you have here you will get there as well. Okay, so assigned IPv4 or IPv6 address, these guest operating system they are getting IP from the DHCP parent IR, say in our case that is 829, and then you can SSH to these devices. Okay, we have some use cases as well, means these company at the moment they are using IoT, and Cisco has done some use cases for these separate things or separate features you can say. In this section we are going to verify the iOS image, a configuration on 8 to 9, and then we'll check the guest operating system running inside this iOS. Okay, so let me log to my iOS for IR800. Let me clear this first. Yeah. So I am logged in inside my IR800, and if I do show version like in normal Cisco devices we are doing, you can see the image. If I do say dir all, here you can see the image. Now the baseline configuration or the configuration we have same that we have in the Cisco devices. So likewise I can do show run and it will generate the running configuration. You can see the running configuration, and we are very much familiar with all these commands and configuration. So let me show you quickly that suppose if you want to configure one interface, in our case the topology is very simple. I have IR with external interface say Gigi 0 and internal LAN interface is say Gigi 5. We'll see that what are the IP addresses we have for LAN and the wide area facing interfaces. Okay, so let me go here and configure the LAN interface first. For the LAN interface my IP address. So let me go to say gig interface 5, and the IP address again the same way that we are configuring the normal Cisco routers and switches, say 192.168, say 1.1, and with /24. Now shutdown. I want this as a inside for the NAT, and I want to enable IPv6. If I do show run and then say interface gig E6 or say 5, because our interface is interface 5, you can see this is the configuration we have over this interface. I can type to so IP interface brief, and I can exclude the unassigned addresses. Here you can see I have inside interface, I have outside interface. So I have my baseline IP address configured. No problem on that. Let us move further and see what is the DHCP configuration. So for that I can do section say DHCP. It will generate the DHCP output. I am excluding address from 1 to 6. That means my first inside or guest operating system IP will be 1.7, and to verify that what I can do, so let me exit so I can show you the options related to that. I can do show IOx and then host. Already I have one host here. Say list and detail. Even after list, if you check what option I have, so I have only one option. Here you can see that in the host registration I have this IOx server address with this particular port number. The IPv4 address is 1.7. The name is this, version is this, and it is up and running. Okay, so I have completed up to 1, 2, 3. Let me close here. Let us complete the other portions in this particular scenario, that to configure the WAN interface, the NAT rules, and how we can enable the debugs. Let me log to the device. I have my device here. Here, first of all, let me show you that how you can set the username. Say username is Cisco with privilege 15, password say 0, and then the password. Okay, so you can see the password. Now suppose if I want to configure the NAT rules, so let me do that. Before that, let me show you that what is the IP address over the interfaces and what is the configuration for the interfaces. So for that I can type show IP interface brief, and I can exclude the unassigned one. In my inside interface, that is my gig 5, I have 192.168.1.1. In the outside interface, I have 198.18135.41. And if I check the interfaces, say gig 0. So for the outside interface, I don't have IP NAT outside configured. That I need to do that. Let me check the inside interface. In the inside interface, I have this IP NAT inside. So let me go to the outside interface, type IP NAT outside. Okay. Now I will do the NAT configuration. For this NAT configuration, the same one that we have in the Cisco normal operating systems, say IP NAT inside. Source I can take a static. Then I want to allow the TCP port, and my inside guest operating system IP address is 192.168 say 1.7. So for port number 22, interfaces over which I want to overload is gig 0, and then for outside port say 22222, like that. I want one more, say 8443, interface is same one, and then 8443. I can check my configuration. So I have these NAT rules, and here you can see I have one NAT called overload. If you want, you can configure that as well. Say something like IP NAT inside source, and then you can give list. I have one NAT ACL that is configured, and I am doing this port address translation, or PAT, or you can say the NAT overload. Okay, so that configuration is there. Let me show you the access list, and then we'll check the NAT configuration as well. Because this is the test type of environment, so I have only one ACL configured called NAT ACL. Okay, now what I can do here, I can check show IP NAT translations, because these are the static translations, and even I can do show IP NAT statics. Okay, so for that I need to go outside. From outside I can SSH to the inside host, and suppose if you want to enable the SSH for inside host, then you need one extra command here, say iOS host, and then exec, say enable SSH for IR 800, say GSO guest operating system, so that will be OS 1. Okay, you can see here system startup links for this. Already this command is already there, SSH enabled successfully, but this is the command that you have to execute to enable the SSH for the guest operating system. So once you enable that, then you have option that from outside you can SSH to this. Before moving further, let us check that what is the line configuration or line VTY configuration. Although we can configure this like, say, line VTY say 0 to 4, transport input is say all, then I can go line 1 to 4, say transport preferred none, then transport input say all, transport output say all, and then I can check the line configuration one more time. I'll check the section of the configuration. So if I am here to the line 1/4, these are the options I have. Okay, here you can see the other options as well. And if I stretch it, let me show you the entire configuration from here. Console, line 1, line 3, all those things we have. Okay, so I am good. What I want to do next, that I want to log into the outside machine. From there, I want to say SSH to my host IP. Okay, so let me log into the remote system, and from there I will SSH to the host machine. Now I log to the remote system. Let me open putty here, and I want to SSH to this guest operating system. Yes. Then I need to give the username and the password. If it is correct, then it will authenticate and log in. You can see here I have logged in, and if I go back, if I check show IP NAT translations, you can see this is the session that I am using here. If I do show users, but you can see that I logged in there. Even I have other option as well. Say from here, if I want to log in, I can log in like this to my guest operating system, say 1.7, and then I have to give the password. Okay, I can type exit. So let me type exit. Let me do one more time. With the correct password. Okay, and then I can type say disconnect. Or disconnect is not there, so you can type exit and you can come out of this. Okay, so this is the way that I can give the NAT rule, and I can SSH to my guest operating systems. You have seen that from outside also. Say if from outside you want to SSH, you need that NAT rule. From inside you can directly SSH. Okay, so these are the things that we can enable here. Let me enable terminal monitor here, because now I want to do some debug. I want to do the debug with help of or with respect to IOx, and the debugging is on. Now what I can do here, I can go to guest OS number 1, and I can stop that. Now it is stopping the guest OS. We'll wait for a moment. We are getting some messages here. Closing connection. That's okay. If I go back to my remote system, power pressed, you can see system is going down. We'll wait. Now what I can do now, that let me do the start. Now it is telling that it is starting the system. Let's move here. And we have this message as success. This is started correctly. Now let us check that what is the IP address here from the DHCP. I will wait for a minute. The IOx server is running. We check show IP DHCP binding. None of the IP address has been binded so far. We'll wait for 1 to 2 minutes. Now you can see some of the messages we are getting, that IOX request register, and if we check the list, now it is getting the IP 1.8. Now if I check my NAT, I need to remove these statements, because now we want this NAT statements respect to 1.8, not with respect to 1.7. So let me quickly remove all these things. And this time I want a NAT rule with respect to 1.8. So let me do it quickly. 8 and even I need to clear the NAT entries as well. Okay, so then only this will come into effect. If I check show IP, say NAT translations, I need to clear this translations actually, and then I need to put it back, say 1.8 and then 443. Now if I check the NAT translations, now it's okay. Let me go to the remote system and let me do it one more time. So restart the session and then the password. I'm in. If I check the translations, I'm getting that. And if I check show IP DHCP bindings, we are good. In this scenario, I will show you that with help of Fog Director, the user interface, how we can manage the application, cartridge, as well as the IOX. Now, what is cartridge? We know that we are using bundle image for IOX, and if you go to a Cisco site and if you go to say product routers, industrial routers, then 800 series, then if you select 8 to 9, and then if you select say software on chassis, IOX cartridge say 120, then you will get all those options related to Yocto based images. Okay, and these are the cartridges. Here we have the option to choose, like for 809 or 829 we have iOS software, IOX cartridge, or we have this IOX Fog node software. Okay, so let me go and log to my Fog manager or Fog director, and from there I'm going to play around with the application and the IOX. Once you log to the Fog director, then you can go to devices. Inside devices, you can add device. Now here you have to give the IP address. We know what is the public facing interface. So that IP is say 198.18.135.41. Then we need to give username and password. Let me do that. Then we have option for tags, contact details, description, etc. I can save this and close. Let me do that. Now what it will do, it will contact to the device, and if everything is correct, then it will add that device. At the moment, initially it was showing that unreachable. Now you can see this green signal. Now this is reachable, and here you can see capacity last heard just now. If I click to that device, this device name is IR100, the serial number, the IP address, the port number. Then we can see the status related to the CPU, memory, disk, and you can check all these options. Okay. We have other options as well, like view this device logs, and we have this logs there, say authentication log, say syslog, DHCP logs. So likewise we have the logs, no problem on that. Let me close this. Download tech support logs. If you want to open a tag case, you can do that. Let me go to the cartridge section and let me verify that do I have the proper cartridge. So actually I'm looking for Python 2.7 and Yocto based say 1.7.2. So these things are here, no problem on that. Then I can go to the app section. I want to add a new app. I want to upload from my computer. Let me select the package. I want this REST sense. Once I select the REST sense package, now you can see that I have options related to the package. Say upgrade package, publish, save. So what I'll do, I'll publish this. But before doing that, let's click here to check the description. You can see the format for that, and then the release notes are there. Now here you can see that the application type is Bash, runtime is Python 2.7, written from Cisco system. It's okay. Let me publish this first. So click to the publish. What is showing here that unpublished app, this RESTSense 1.6, and I need to install this, so let me install this. While you are installing this, then it will ask you to select the devices or add the selected devices. You need to select. So here I have only one device. Let me add that. Here in the bottom you can see it has been added. Click next. Now here you can see that done. Let's go. Means you can see it's very much click and go next type of thing. Simply we are uploading the package, publishing it, installing it, and then we are selecting the device, and we are pushing that configuration to the device. So these things we are doing step by step. Now once we reach up to this point, you can see that we have error message here. Let's fix this. Let me go to the configure network. Let me click here. Here, click here to this gray box, and from here select the IOx bridge 0. The IOx bridge is dynamic, that's okay. And then click done, let's go. Once we'll do that, then we'll get the progress bar. So here it is showing 0%, now 16%, like that. We'll wait till it reaches to the 100%. Once we are done, then if you see the app section, so from here if you see the app, you will find that okay, installation app 1 successful, is 1 device, like that you will get that. Okay, so this is the way that inside the fog we can add a device and we can install a application. Let us continue our discussion. Now what I can do, I can go to devices. Inside this I can go to my application. I can stop this application. Once I click here beneath this action, then you will get two icon. One is for restart, one is to remove the app. Again I can click here to start this, and even I can go to say settings. Inside settings I can download the logs. You can see it has been downloaded. Let me go back to the devices, and if I go to this device, actually this is the device dashboard. So once you click to the IR100, you reach to that particular device, because in this fog director you may have n number of devices. Okay, now you can see this message used, available, like this. Now from here, if you want to collect the log, so let me click here to view device log, and I want to check the messages. Then you will get those messages. Okay, so that is the one thing, that we have stopped the application, we have restart that application. Now I can go to my app section, and here inside this app status in this green box, let me click to that app status, from where you will get this monitoring view. So these things already I have discussed in my earlier recording, that inside monitoring view you can monitor the CPU, the disk, memory, network consumption. Because we have just started our application, it actually required some 30-minute to 1 hour buffer, so it will display the monitoring status or the monitoring logs or the graphs here. Okay, so this is one of the monitoring view. From there I can come back to this section. Let me go again to the devices. Again, let me go to this particular device dashboard. Here you can see the device detail. Then I have detail for the cartridge. Let me scroll a little bit down so you can see that Python and Yocto 172. Then any outstanding action, if you have any pending action, it will show you. Okay, so you can see that how user friendly this particular uh, what you can say this fog director is. Suppose if you want to add new cartridge, you can click here, select your cartridge package. You can download from your local system, and once you download it, it will be uploaded here. Okay, so it's very simple, but it's very powerful, because from this fog we can go and reach to all of the nodes, or all of the things. In our case, that is the things. So this is the power of this fog director. From here we can easily install the application, we can monitor, we can refill the cartridges, we can get the monitoring, we can get the device dashboard, their status, CPU status, memory status. So all these things we have in a single place.